Hello dear students of plus 2 medical, non-medical and respected teachers. Today I am going to discuss a very important topic from chapter of semiconductors. It is last unit of plus 2 physics, that is transistor as an amplifier. How transistor acts as an amplifier, which is one of the important application of a transistor, junction transistor. So amplifier is a device which amplifies the output voltage. When we give some input and it gets amplified in the output, then that device is known as amplifier. So first of all, there are two types of amplifiers of transistor. First is common base transistor amplifier. So first of all, make the connections as shown in figure. This is transistor, load resistance, two batteries. One is known as emitter based battery, collector based battery, and there is a gap to supply input AC voltage. So in this diagram, it is NPN transistor. So according to which emitter is always forward biased. That is, input circuit is always forward biased, whereas output circuit is collector is always reverse biased. So in case of common base transistor configuration or in any transistor as an amplifier, input circuit is always forward biased, output circuit is always reverse biased. So connections are made accordingly. So this is N type, so it is connected to negative. This is P type, so that is forward biased. This N type is connected to positive and negative is connected to the central base positive. That is, this is reverse biased. Now, when no AC input signal is fed to the circuit, कोई signal नहीं देता पहले. When no AC signal is fed to the input circuit, then what is the effective voltage between collector and base? Effective voltage between collector and base, that is VC. VC is given by VC is equal to VCB, supply voltage between collector and base, minus ICRL. So this ICRL is a voltage drop across the load resistance in accordance with Ohm's law. So effective voltage between collector and base when no AC signal is fed, then is given by VC is equal to VCB minus ICRL. Say equation number 1. So this equation will explain the amplifying action of the transistor very easily. Now, first of all, when this input signal is fed, AC signal is fed, first of all, suppose positive half cycle falls. When positive half cycle falls, it means it opposes the forward bias because it is negative. It opposes the forward bias means forward bias decreases. As a result, emitter current decreases. As a result, collector current also decreases because collector current depends upon emitter current. So if collector current decreases, this factor ICRL decreases because RL is fixed. If ICRL decreases, means this negative factor decreases. So VC becomes more positive because VCB is also fixed. So it means instead of small positive half cycle, we get amplified positive half cycle in the output of the amplifier. Now, similarly, when negative half cycle falls, this negative half cycle adds to the forward bias. As a result, forward bias increases, means emitter current increases, means collector current increases. If IC increases, ICRL increases. If ICRL increases, this negative factor dominates. So it means VC becomes more negative. So instead of input, small input negative half cycle, we get amplified negative half cycle. So this is how input AC signal is amplified and we get amplified positive and negative half. And it is very clear that in case of common base transistor amplifier, input and output are in phase. There is no phase difference. And if we define current gain, in case of common base transistor amplifier, it will be change in collector current to the change in emitter current. Current gain, change in collector current to the change in emitter current, i.e. So this is alpha AC. Similarly, we come to common emitter transistor amplifier. Now, in case of common emitter transistor amplifier, again we take NPN transistor, make the connection as shown figure, so that input circuit is forward biased, output circuit is reverse biased. So this is NPN, so base is coming, emitter is common. So base is connected to the positive, so that it is forward biased, emitter to the negative, and collector to the positive and negative terminal to the emitter section, so that collector section is reverse biased. Again, when sorry, no AC signal is fed to the circuit, effective voltage between collector and emitter in this case is given by VC is equal to VCE minus ICRL, because VC is the supply voltage. So effective voltage will be VC is equal to VCE minus ICRL, because ICRL is the voltage drop across the load. So from this, say this equation number 2, and from this equation we can explain the working or action of this common emitter transistor amplifier. Now, first of all, when positive half cycle falls, it will add to the forward bias. As our forward bias increases, means emitter current increases, means collector current increases, means ICRL increases, means this negative factor increases. So VC becomes more negative instead of more positive. So we get amplified negative half cycle when positive half cycle falls. Similarly, when negative half cycle falls, it opposes the forward bias decreases, emitter current decreases, collector current decreases, as result ICRL decreases, so VC becomes more positive. Now we get an amplified positive half cycle. So it is very clear that in case of common emitter transistor amplifier, input and output are out of phase by pi. Out of phase by pi. So pi is the phase difference. And because in case of common emitter transistor amplifier is preferred because it has high gains. So various current gains in common emitter. First DC current gain, beta DC is IC upon IB, because emitter is common, so it is alpha upon 1 minus alpha. We had derived this equation. This is DC current gain, which is defined ratio of collector current to the base current, and again by beta is equal to alpha upon 1 minus alpha. AC current gain, it is defined as change in collector current to the change in base current. AC voltage gain, it is defined as change in output voltage, that is change in collector voltage to the change in input voltage, or delta IC into R0 upon delta IB into Ri, where R0 is output resistance, Ri is the input resistance. So delta IC upon delta IB is nothing but beta AC, R0 upon Ri is called resistance gain. So it means voltage gain is equal to current gain into resistance gain. Then transconductance G, M. Transconductance, these are some parameters. Transconductance Gm, it is defined as the ratio of change in collector current to change in input voltage. It is transconductance multiplied and divided by delta IB. So delta IC upon delta IB, delta I upon delta VI. Delta IC upon delta IB is nothing but beta AC, and this is nothing but 1 upon Ri, that is Gm is equal to beta AC upon Ri. This is the expression for transconductance. Power gain. Power gain is defined as ratio of change in output power to change in input power. So output power will be delta IC into V naught. Input power will be delta IB into VI. Delta IC upon delta IB nothing but current gain, and V naught upon V nothing but voltage gain. So power gain is equal to product of current gain and voltage gain. So this is how NPN or PNP transistor acts as an amplifier. So transistor can also use as switch. So many applications. So transistor can also use as an oscillator. We'll discuss in the next video. So till then, stay tuned. Be happy. All the best. Good luck. Sarbat Dapala.